Good morning or afternoon, IED students. This is the 3.5 Introduction to Summary Statistics screencast. So do yourself a favor, get out your engineering notebook. You are going to be expected to take notes during this presentation. If at any time you need to pause this screencast to be able to make sure that you are taking notes, please do so. You will note that the slides that you need to take notes on are indicated by the Bitmoji either in the bottom or right or left corner of the slides. So without further ado, let's begin. So we're going to start by talking about statistics. Statistics are the collection, evaluation, and interpretation of data. That means that we are collecting numbers and quantities based upon testing, and then we are putting them together in a pattern that makes sense so we can draw a conclusion. Statistical analysis of measurements can help verify the quality of a design process or product. That means that when we gather data, we can use it to determine if something is of the quality that we need or not. Now we have a couple of different types of statistics known as summary statistics. The first grouping of statistics that we have are called central tendency statistics. They are the center of a distribution, and they include things like mean, median, and mode. We can also have variation statistics. These are the spread of values around the center, okay? And that includes range, standard deviation, and interquartile range, okay? And then we can also have distribution statistics. Okay, they're a summary of the frequency of values, so that would include frequency tables, histograms, or if something is normally distributed. Don't panic if you don't know what these words mean at this point. We are going to be talking about these in more detail as we go through this presentation. Okay, so I'm going to buzz through these next couple of slides because they focus on mean, median, and mode. You'll notice that there is no Bitmoji on these slides. That's because mean, median, mode are things that you guys have been doing in math class probably since the 4th grade. So I'm going to do a very quick review and move on to the content that I feel is newer and probably going to give you guys a little bit of a harder time. So as you know, a mean is the sum of the values of a set of data divided by the number of values in the data set. The mean is represented by this symbol right here. That's the Greek letter mu. It's a letter U with a slightly longer line. And this is the technical formula for calculating mean. You guys know that when you have a data set, you add up the numbers, divide by the number of numbers, and that gives you your mean or average. Okay, so here this explains that formula. Again, I talked about mu being the mean value. So xi is your individual data value, and then the summation of all the data values. This big E is a sum symbol, so this means the sum of all the individual data values. And then n is the number of data values in the data set, so the number of numbers that you added up. Okay, so this is an example of mean. I am not going to go over it. You are welcome to go back and look at it later. Okay, so really quickly though, a note about rounding in statistics. The general rule for this, now I know we've talked about significant digits and everything, but right now when we're working with statistics, you should not do any kind of rounding, cutting off, significant digiting until your final answer. Okay, if you are writing intermediate results, you may round values, but you need to keep the unrounded number in your memory. And that means if you're documenting your work and you don't want to write 10 decimal places, that's fine, but make sure you know what those 10 decimal places are so you can keep using them to actually solve the problem. If you round too early, it causes issues. So the mean, round to one or more decimal place than the original data, and standard deviation, round to one or more decimal place than the original data. We are probably going to tell you specifically how many decimal places we are expecting, so make sure you read your directions thoroughly as you do this activity. Okay, so again, another example with mean is in rounding. Moving on, mode. As you guys know, mode is the measure of central tendency. That's the most frequently occurring value in a set of data, okay? And the symbol for that is a capital M. So, again, looking at this, because there's two 21s, that's the mode. Pretty simple, okay? Now, we can have bimodal data sets where two numbers of equal frequency stand out, or multimodal data sets where more than two numbers of equal frequency stand out as well, okay? So, these are, again, more examples. This is just a regular mode. This is bimodal. And this one is multimodal. Okay. Median, again, you guys are aware of median. It's a measure of central tendency. It's the value that occurs in the middle of a data set. The symbol is X, pronounced X tilde. That's because it's in italics. Okay. So again, median is the value that occurs in the middle of the set. Okay, once we rearrange those numbers in numerical order, we then get our median, or x tilde, 21. Okay, here's another example. Range. Please note, we're back to taking notes. So range, you probably have talked about it. I'm sure you've looked at it before, but it's a measure of data variation. The range is the difference between the largest and smallest values that occur in a set of data. Okay, the symbol for range is a capital R. So if we look at this data set, we need to subtract 3 from 44. Okay, so it's the maximum value minus the minimum value. That's going to be 44 minus 3 is 41. So our range would be 41. Now this is where it gets a little bit trickier. This is standard deviation. So for those of you who have seen standard deviation before, awesome, cool, this will be a review for you. For those of you who are like, standard deviation what? Please make sure that you pause, repeat this slide, or repeat this part of the recording if you need to. So standard deviation is a measure of data variation, and the standard deviation is a measure of the spread of data values, so how far apart the data values are. So a larger standard deviation indicates a wider spread in data values, okay? So looking at this crazy formula for standard deviation, let's break this down. Right here, the little loopy O symbol, okay, is what stands for standard deviation. So anytime you see this, that means you are solving for standard deviation. Xi is the individual data value. We saw that in the mean formula earlier. Xi means that it is just one of your values. Then we see the symbol for mean again, so we have that mu. Okay, mu is for mean, and it's located up here in the formula. And then n is the size of the population, so that's how many data values we have in the data set. So in order to solve for standard deviation, we have the sum of the individual values subtracted with the mean subtracted from it. So we take the individual data values and we subtract the mean. We then have to square that and add up all of those values to get that sum. Okay, that's then subtracted or then divided by the number of values we have in our data set and square rooted. Okay, if you don't have a scientific calculator, this is where you're going to want to maybe put an app on your phone, because squaring and square rooting is much easier to do on a scientific calculator. Okay, so the procedure for going through and calculating this formula, just to recap what I said, first you're going to calculate the mean, which is mu. So we need to find the mean of our data set first. Then we have to subtract that mean from each value and square each difference. So we would start by taking an individual number and subtracting the mean from it. Once we have all of those for the entire data set, we would then go through and square all of those values. We then have to add all of those squared values together and then divide by the size of the population, so the number of data values. Then we have to square root that total number in order to be able to solve for our standard deviation. Okay, so just a reminder about rounding in statistics, don't round until your final answer. And again, if you're writing things down and you don't want to write 10 decimal places, that's fine, but you need to make sure that you are that you are keeping the original values so that way you are able to calculate correctly. Okay? All right, so let's look through this example for standard deviation. So this is the data set that we're working with: 2, 5, 48, 49, 55, 58, 59, 60, 62, 63, and 63. Okay, we'll start down here by calculating the mean. So we add up all of our data set, we add up all of our numbers and divide by the total number, which is 11. That's going to give us a mean of 47.63. That's what we're working with. So now we have to go through every single value in our data set and subtract the mean. So we start with the number 2. 2 minus 47.63, and then square it is 2082.6777. Now, if you would prefer to just subtract the mean and write that value, then square it, that's fine. It chunks it a little bit more, might make a little more sense. But the reality is we are subtracting the mean from the value and squaring it to be able to get our final value. Because obviously when we subtract this from 2, we're going to have a negative number. Once we square it, it becomes a positive number again. So don't freak out if you see negative numbers popping up for some of these lower values. Okay, so again, we calculated the mean, good to go. We subtracted the mean from each data value and squared each of the differences. Awesome. Okay, so then we have to sum all of the square differences. So right here, you'll see that we have added all of those values that we calculated together. This gets our number, okay? So note that this is the sum of the unrounded squared differences. We did not round at this point, so these are the unrounded values. Okay, then we have to take that number and divide it by the total number of values in our data set. That's 11, so we're dividing 5,024.5455 by 11. That's giving us 456.7769. Our step after this is to square root that number, so we take the square root of 456.7769, and we get 21.4. Okay, so that was the end of standard deviation. If you would like to pause and go back to review that, go ahead. I'll wait right here, and we can talk about histograms. All right, so looking at histograms. A histogram is a common data distribution chart, so it's a graph that is used to show the frequency with which specific values or values within ranges occur in a data set. Okay, we might use histograms to show the variation of a dimension that exists among a group of parts that are intended to be identical. So let's say we as a class manufactured boxes. We might use a histogram like this down here in the corner to show the different variations in our box sizes. So if we were all trying to make the same exact box, we might have some very minor deviations because someone didn't glue it properly or someone didn't cut a piece properly. And so we can use a histogram to show the differences in the various boxes and where the majority of those errors or differences occur. Okay, so a large set of data is often divided into a limited number of groups. Okay, these groups are called class intervals. So when we go to make a histogram, we have to take our data and we put it in ranges that are called class intervals. So down here, you'll see we have a class interval that's -16 to 6 to -6, -5 to 5, and 6 to 16. That breaks our data into 3 separate chunks. The reason we do that is that we can then graph these based upon those ranges. So the number of data elements in each class interval is shown by the frequency, which is indicated along the y-axis. So what this is telling us is that we have just about 5 values that are in the -16 to 6 range. Okay, just about 7 values in the -5 to 5 range, and then about 3 values in the 6 to 16 range. So let's say we're talking about those boxes again, and we have an accepted deviation of -5 to 5 in terms of our measurements. That would tell us that most of our boxes fall within the acceptable values, but we do have 5 and 3 that do not. So that's how we can use a histogram to check ourselves to make sure that we are doing what we need to be doing, and we can also visually represent the differences in objects and data that we collect. Okay, so here's an example. We have the numbers 1, 7, 15, 4, 8, 8, 5, 12, and 10 in our data set. So we are going to create class intervals that are 1 to 5, 6 to 10, 11 to 15, with a frequency of 1, 2, 3, and 4. So our class intervals go across the bottom, our frequency goes across the top. Okay, so now looking at this, the places that we point our little arrows to are actually half a point above our final value. So we have 0.5 here and 5.5 over here. Okay, it goes up to 10.5 and then 15.5. So these are just these little mathematical equations right here just represent the rate, it's basically just explaining how we end up placing our little markers. All right, so now we're going to go through and we're actually going to graph that. Okay, so if you look, the number of values that we have from 1 to 5, we have 3 of them. We can manually calculate that up here or just look at the graph. In the range of 6 to 10, we have 4 values. In the range of 11 to 15, we have 2. This is again just an example of a histogram. Okay, there's our minimum, there's our maximum. Okay, now this is talking about a dot plot. We can use a dot plot to actually create a histogram as well by mapping things out and then identifying our class intervals based upon that. So this is just obnoxiously putting all the dots in place. We can then identify the frequencies with the dot plots and actually color them in using the bar chart. Okay, now looking at normal distribution, This is a bell curve. A lot of you have probably seen this in math classes. This is just saying that our data, when we graph it, looks like a bell. Okay, it has this curvature shape to it. Hi there, Barons. We are back. So now that we've gone through the PowerPoint for 3.5, I am now going to go over the activity for your deliverable. So you inside of Classroom have this document. I'm going to go over it with you, and then you are going to have time to complete this. So this is for 3.5 Applied Statistics. If you do not have this document open, I would highly recommend pausing this video and going into Classroom and opening your version of it so you can follow along and maybe type some notes into it if you need to, just so you can remember what it is you need to do for this assignment. So, first of all, your introduction for this assignment is today's consumers are constantly trying to judge the quality of products, but what is quality? How and by whom is quality determined? Some would say the designer creates specifications, which in turn dictate the quality of the product. That quality is also based on the acceptable value of a part within a whole product. So we talked about this a little bit in the presentation with the box example I gave you. Anytime we create a product for commercial sale, there's always a tolerance of how much we can accept in terms of error. So whether it's too big, too small, a little bit off of the ideal size. And we use statistics to resolve this during the manufacturing process, and that's called quality control. And then we maintain quality by making sure that we have that quality control. So in this activity, you are going to use this data to complete it. So our procedure is that part of the manufacturing quality control testing for a toy is to measure the depth of a connector piece that must fit into another part. The designed depth is 4.1 centimeters. Every 10th part produced on the production line is measured. So then the following data was collected during a 2-minute period of production. So in your brain, you can picture an assembly line, all these parts are coming down through, and every 10th part during a 2-minute period is picked up and measured. So this is the data that was collected. So you are now going to use this data to calculate the following measures of central tendency, and you need to show your work. Now we want to see final answers in these boxes. The work should be, you guessed it, in your notebook. So make sure that you're typing your final answer here, but that work gets documented in your notebook, and then you're going to upload those images along with your assignment, just like you did previously. So again, this is the data that you're using, and you're going to calculate the mean, median, and mode. If you do not remember how to do that, go back to the PowerPoint. It'll walk you through. And then you're using that same data to calculate these values down here. So you're going to use this data to calculate the range. Remember, the range is the difference between the maximum and minimum value. Please note, these are not in numerical order right now, so you're going to have to fix that. And then this big table down here is to help you calculate standard deviation. So you'll notice that in this table, there's 3 columns. We have an X column. We have an X minus U, or mu, or mean column, and then we have an X minus mu squared column. So basically we've taken the process for creating the standard deviation and we've broken it into pieces. So the first thing you need to do is get these values, and you need to place them into the various columns down in this table. So you're going to put the values as your X values in this column. You are then going to subtract the mean from each of these values. So 4.1 is in this box. You're going to subtract the mean from 4.1 and put that value into this box. Remember, in some instances, depending on the size of your mean, at this point you may have a negative number. That's okay. So after you've gone through and filled in that column by subtracting the mean from all of the values located in this data, okay, we are then going to square these values. So you're going to take this number, X minus the mean, and square it and put that final answer in here. So after you have that table filled in, you are then going to add up just this column. So all of the numbers in these columns, or in these cells right here, are going to be added, and that's going to give you the sum of the X minus mean squared. You're going to need that because you're going to have to go back into your notes and find the standard deviation, and then finish using the values up here to solve for the standard deviation of this data. So that formula is not included on this worksheet. You're going to have to pull it from your notes. After you finish that standard deviation, as well as filled out this table and everything is in your notebook, make sure you take pictures of those notebook pages and attach them to this assignment or add them to the bottom of the document so we can verify that your work has been completed. And then make sure you turn it in. If you have any questions, please see me or Mr. Kapersky, and good luck. Get to work.